So now we are moving on to constraint optimization. The general idea is exactly the same as the previously studied unconstrained optimization on Excel solver. You're still gonna have the objective function determine max or min according to the question, according to the context, specifying the choice variable or the independent variable that you are to solve. The only difference is you are to add the constraint. Okay, so we actually have done this when we were solving system equations using the constraint method. And here you're just changing the equality into maximization or minimization. So let's look at the first example, which is the example 1 of slides 5-3. So here we're going to just directly derive the result. All right. So here we were to maximize the function. Okay. And the constraint is this subject to. Okay. All right. So what you are to do is actually pretty straightforward. First, determine x and y, and then we have a function value, which is 120 by x minus 4 times of x squared plus 2 by x by y minus 3 times y squared plus 96 by y minus 102. Okay, so this is the function. 100 by x minus 4x squared plus 2xy minus 3y squared plus 96y minus 102. Okay, we got this. Then we need to figure out the constraint. Okay, which is underneath. And here we have left-hand side and right-hand side. The right-hand side is just 96, and left-hand side is the function 3 times x, x plus 3 times of y. X plus 3y. Okay, so we have things set up. We just translated everything here into the solver programming. So now we just need to apply the solver, go to data solver. What we are to do is we are to maximize this function, right? By choosing x and y, by solving out x and y, okay, subject to the constraint that your left-hand side is smaller equal to right-hand side. You can manually key in 96, or you can just click the cell, click on the cell too. Okay, so just this, and here we relax the constraint because there is no requirement that x and y has to be positive. And we let it solve. We have x equals to 18, y equals to 17. Okay, just one additional thing to add, which is at here, after you doing solver, right? Ask it to solve, and here you can actually click sensitivity. Okay, sensitivity report. Let me do it again. So after selecting solver, hit solve. In this chat box, solver result, you can actually go to sensitivity report, select the sensitivity report. Okay. And here we have sensitivity report 1. So what is the use of that? The sensitivity report actually reports the value of Lagrange multiplier, which is lambda, and here lambda equal to 10. And this final value is the value of the function, which is, I'm sorry, the value of the constraint, which is 96. Okay. And the value of the function is 2139. So here, what this lambda is to tell you, if this constraint is relaxed from 96 to 70, how much the function value, the optimal function value will be, which is supposed to be increased by 10 units. That's what the lambda is telling you. So the sensitivity report, the key goal of the sensitivity report is directly report to you what the value of the Lagrangian multiplier is, instead of having to solve the Lagrangian multiplier by hand through first order conditions. Okay, and here those are the final values of x and y, which is x equal to 18, y equals to 17. So that's how to do this constraint optimization with Excel Solver.